for all 523 square meters of the Sistine Chapel ceiling in his stunning frescoes. That works out to about 1 square meter every 16 hours. Rome's area is 1,285 square kilometers, so it would take 20 billion hours, working at Michelangelo's meticulous pace, to construct all of Rome. If 8 billion workers all pitched in, they could do it in about 2.5 hours. So there you are. 8 billion people could build Rome in somewhere between 15 minutes and 2.5 hours. Next question. How much spaghetti is needed to feed 8 billion people lunch after they've just built Rome in under a day? Assuming you're in a totally indestructible glass tube extending from the ocean's surface to its bottom, what would it be like to stand at the deepest part of the ocean? The answer to that question depends on whether or not you brought a nice thick sweater and a torch with long-life batteries down to the bottom of the ocean with you. If your totally indestructible glass tube stretched from above the surface of the sea right down to the deepest depths of the Mariana Trench, you'd be 3 times deeper below sea level than the world's deepest mines. In a mine, the deeper you go, the hotter you become. That's because mines are drilled into rocks, which grow hotter the closer they get to Earth's core. But the temperature at the bottom of the ocean is only slightly above freezing. So you're going to be cold. On the plus side, you'll be able to see one of the least visited sites on the planet, the floor of the Mariana Trench. Just kidding, you won't be able to see much at all unless the sun passes directly over the mouth of your glass tube, which it will do exactly twice a year, around April 20th and August 23rd. After that, it's another 6 months of total darkness. Unless that appeals, you should probably get in your elevator and come out. You did put an elevator in your totally indestructible glass tube, right? I'll take that silence to mean no. Well, at this point, you could always knock a hole in the side of your glass tube to let in water, which, in turn, will carry you up above sea level. But make sure you're standing well clear of the hole itself. When that hole opens, a supercharged jet of seawater is going to charge through it. In fact, even if you could somehow stand clear of the hole, just letting a whole bunch of water rush into the bottom of your tube isn't the best idea. The column of water that would rush upward would have a Mach number of 1.3. If you tried to ride this column of water upward, you wouldn't survive the impact. Your best bet would be to let water through in a slow, controlled fashion, perhaps through a tap at the bottom of the tube. After your tube has filled up with 1 kilometre or 2 of seawater, only then would it be safe to fully open the bottom of the tube to let more seawater rush in. And provided you had a giant plunger on hand to keep all the water safely underneath you, you'd be back above sea level in less than a minute, travelling on a giant fountain of icy water at a speed of 500 miles per hour. Okay, let's revise that packing list, shall we? Sweater, torch, tap, giant plunger. You're good to go. Could a person eat a cloud? Clouds are made of air and water's edible, right? Or potable, at least. So in theory, there should be nothing to stop a person from eating a cloud, apart from, common sense, having better things to do with one's time, and the challenges of getting a cumulonimbus to sit still on your plate. But here's the problem. Unless you could come up with some way to squeeze the air out of the cloud before you started chewing it, it's going to be impossible to ingest. Let's say you put a piece of cloud in your mouth. You can swallow the water it contains, but you'll be left with an abnormally large quantity of air inside you. Your body will need to let the air escape, in this case by burping. The thing is, once air has been inside your body, it absorbs moisture. When you burp out that nice, warm, moist air, and it meets the cool outside air, it will condense and form cloud, more cloud. You'll end up burping cloud faster than you can eat it. Let's imagine you could extract a cloud's water content by passing the cloud through a very fine sieve, or by ionizing the water drops and extracting them with an electrical charge. In that case, you'd definitely be able to eat a smaller-sized cloud. A cloud the same size as a small house would contain between 2 and 3 litres of water, which just so happens to be the maximum amount of liquid the average human stomach can comfortably hold at one time. There's certainly no other foodstuff you'd be able to eat in house-sized quantities. Even an extremely low-density food like cotton candy is way denser than a cloud. At most, you'd be able to eat about 1 cubic foot of cotton candy in one sitting. On the plus side, it might be more delicious than your average cumulonimbus. How big would a snowball grow if it was rolled from the top to the bottom of Mount Everest? Snowballs only grow in size when they're rolled through wet, sticky snow which adheres to their surface. Mount Everest is covered in dry, fluffy snow, so even if you did manage to roll a snowball from the top to the bottom of Mount Everest, your snowball would stay about the same size it was when you first rolled it. Hypothetically, if Mount Everest were covered in wet, sticky snow, how big would your snowball grow? Well, the bigger a snowball gets, the more snow it picks up. So it stands to reason that the more time a snowball spends rolling, picking up more and more snow, the faster it will grow. After all, we wouldn't use the word snowballed to refer to exponential growth if it weren't 100% accurate, would we? Yeah, about that. The more snow a snowball picks up, the greater its surface area becomes. Each new patch of snow has to cover way more area, meaning a snowball's growth will actually slow the longer it spends rolling. Unless you're using snowballed to refer to something that starts growing at exponential speed and then slows right down, you're not using it right. Now, the journey from the summit of Mount Everest to base camp isn't all downhill slope. There are lots of flat glacial valleys where a snowball would roll to a stop. But the mountain's 3 main slopes each have drops of about 5 kilometers. Theoretically, a snowball rolling down one of these slopes could ultimately grow to between 10 and 20 meters wide. Theoretically, but not practically. In reality, a snowball would collapse under its own weight before it reached a width of more than a few meters. It would then break up into smaller snowballs, which would each start to grow until they too broke apart into even more smaller snowballs, which would each start to grow, and so on and so on. In short, if you tried to roll a snowball from the top to the bottom of Mount Everest, it wouldn't grow very big. The avalanche you might cause, on the other hand, could be fairly substantial. That's it. We're done. Thanks for listening to this blink to Randall Munroe's What If 2. I hope you've learned that science doesn't have to be serious and math needn't be monotonous. Stretching your brain by trying to find the answers to silly questions is a great way to train your analytical mind while still having some fun. All right, see you in the next blink. And please leave us a rating or a comment.